In this video, we're taking a close look at AutoSxS, a comparative evaluation tool for large language models. Imagine working on an AI project where you need to choose the best model for summarization. Without clear comparisons, it feels like guessing in the dark. Good news is, with AutoSxS, you're able to perform side-by-side evaluations of the outputs of two different models. By the end of this video, you'll be able to understand how AutoSxS works, the role of the autorater, and how to use it to compare model outputs. You'll gain insights into evaluating LLMs with a clear understanding of what makes one model's response better than the other. AutoSxS is an evaluation tool that compares two LLMs side by side. It utilizes an autorater, or a judging model, to determine the better response to a prompt. Using this tool, you can assess the performance of any generative AI model for summary and question answering use cases. AutoSxS also provides explanations and certainty scores for each decision. At the core of AutoSxS sits the autorater, which makes this comparative evaluation possible. The autorater is an LLM specifically designed to assess the quality of responses generated by other models when given an original inference prompt. AutoSxS can evaluate any model with pre-generated predictions and can auto-generate responses for any model in the Vertex AI model registry that supports batch prediction. Currently, it can evaluate the performance of models on summarization and question answering tasks. For each side-by-side evaluation, AutoSxS employs predefined evaluation criteria. For example, some criteria for summarization include how well the model follows prompt instructions, how grounded is the response in the inference context and instructions, how well does the model capture key details in the summarization, and how concise is the response itself. Using AutoSxS is pretty straightforward. First, we prepare a dataset of prompts, contexts, and corresponding generated responses, only if input prompts required. Then, we store the evaluation dataset to Google Cloud's storage or a BigQuery table. And then, we perform the model evaluation by running the evaluation pipeline job. In the next video, you will see a demo of AutoSxS in action, comparing Gemini Pro with another LLM for a summarization task. But before that, let me explain how each of these steps work. AutoSxS accepts a single evaluation dataset. The dataset must include at least one example, but for proper evaluation task, something around 400 to 600 examples are recommended. Each unique example has a unique ID and includes content and responses. We also can add an additional column for taking human preferences into account as well. Next, we must set parameters for performing the model evaluation. For example, in a model evaluation without human preference, the parameters might specify the evaluation dataset, columns to use, the task, for example, summarization or question answering, and autorater prompt parameters like the inference context and instructions. We must also provide the columns containing predefined predictions to calculate the evaluation metric. After defining our parameters, we can initiate an evaluation pipeline job using a Google-provided template. The parameter values are passed in to configure the pipeline job. AutoSxS utilizes Vertex AI Python SDK to get this job done. After successfully completing an AutoSxS evaluation, you can view the evaluation results. AutoSxS generates three primary types of evaluation results: judgments table, aggregated metrics, and aligned metrics if human preference are provided. The judgments table indicates the superior response, and each choice is accompanied by a confidence score, which is a value between 0 and 1. The auto side-by-side judgments include an explanation of each of the autorator's choices. Auto side-by-side can generate and compare multiple outputs for a given task to select the response judged as better based on criteria like coherence, logical flow, and capturing the key points. For example, when choosing between response A and response B, the autorater might explain that while both provide good summaries, response B does a slightly better job of capturing the overall story in a more coherent and organized manner compared to the more statistics-focused response A. Auto side-by-side also provides aggregate metrics. These win rate metrics are derived from the judgment table as a percentage of times the autorator preferred one model over the other. These metrics help to quickly identify the superior model. Also, as I mentioned earlier, auto side-by-side allows for the validation of judgments with human preference. This means providing additional information and parameters within the side-by-side evaluation pipeline is possible. In order to do so, in the dataset, a column must be added for human preference. We also need to define human preference column within the parameters. The rest of the process remains the same. Including human preference results in additional metrics for human preference alignment. And the output includes all the regular metrics, but it also includes a human preference win rate along with the autorater win rate, and a coherence kappa score, which denotes the level of agreement between the autorater and the human rater. Again, this is a value between 0 and 1, with 0 being random choice and 1 being perfect agreement. In conclusion, auto side-by-side stands out as an innovative tool in Vertex AI for evaluating and comparing the performance of generative AI models. We've seen how it brings precision to the evaluation process with side-by-side comparisons and detailed explanation features. It streamlines the assessment of LLMs, ensuring that the best performing model can be identified based on task-specific criteria.